Yep, that was the button. A little bit that way. I hope that's flat. Anyway, okay, so guys, last time we took the empirical formula and we came up with percent compositions by converting the formula into the number of moles, basically multiplying it by the molar mass. Today, we're going to go the other way. We're going to use the we're going to use the percent composition to come up with an empirical formula. And to do that, we have to remember what percent means. How many cents are in a dollar? 100. How many years are in a century? So what does cent mean? 100. So in percent, what we're talking about is per 100. So what we do is when we are given percents, we pretend like we have 100 grams of the stuff. Okay? The good stuff. Definitely the good stuff. Always the good stuff. The best. The best. It's the best. It's the best stuff ever. It's the best. There's no better stuff. It's going to be a huge stuff. Make you very happy. But anyway, so yeah. So if you're given a pie chart and you're told that you got 65% of, let's pretend that's 45% there, and 55% there, then if you had 100 grams of stuff, this would turn into 55 grams of that stuff and 45 grams of that stuff. Make sense?
Certificate for Sarah.
Congratulations for Sarah Harvey. Okay. Oh, student of the quarter. Only the best.
No breakfast.
You didn't go to your breakfast.
I know.
Okay, so anyway, so when we're turning percentages into empirical formulas, we pretend like we have 100 grams of the stuff. So we just take the percent and turn it right into grams. Then we do that skill that we started learning in September, and I told you we're going to use a lot, and we turn the grams into moles. Remember how in September I told you that we were doing this? Yeah. And then in January we were going to do this?
Oh boy.
Yeah, well, this is coming up. This is next week.
No.
Yes.
No.
I'm writing down who's getting the S's and who's getting the O's right now.
Yeah, I'm getting an A.
Okay, so once we have the moles, once we've converted our grams to moles, we turn those moles into ratios, and those ratios become the empirical formula. Okay. So we'll do a few together, and then I'll turn you loose. So this is how you do it. Let's start simple and small with... By the way, any questions before we begin? Okay, follow along. If we have a compound that's 27% carbon and 73% oxygen, we just turn that into 27 grams of carbon and 73 grams of oxygen. Okay? In a 100-gram sample, the percentages just turn right into 100 grams. Make sense? Then we're going to use T-charts to turn these into moles. So 27 grams of carbon, make our T-chart, grams of carbon to moles of carbon. Mole gets a what? 1. And where do I find that mole to gram ratio? From the periodic table. It's either that way or it's that way. So it's either on your desk or it's on the wall. The periodic table gives us the gram to mole ratio, what we call the molar mass. So how much does a mole of carbon weigh?
Isn't it like 12 or something? 13.
12? That's the number of atoms.
12.9.
Yeah, so it's 12. So it's 12.01. So 12 grams. So the periodic table tells us that there are 12 grams in 1 mole of carbon. So we turn our 27 grams of carbon into moles of carbon, and that's going to give us a number. We're going to do the exact same thing to oxygen. We're going to take the 73 grams of oxygen, and we're going to convert that. 1 mole of oxygen is so many grams of oxygen. 16, if you say so. And that's going to give us moles of oxygen, moles of carbon. So if you don't already have a calculator, grab one so you can bang on it for a while.
I'm just going to grab like 6.
Just take the whole charger.
This one's for me and these ones are for you.
How cool they're blue and yellow. I didn't even plan that. TI just made all the yellow ones for teachers and I got blue calculators. Oh, scientifics are gone. You have to use a graphing. All right, guys, so now that you have your calculators, find out how many moles is 27 grams of carbon and how many moles is 73 grams of oxygen. 2.25? 2.25 and 4.6. Sounds good. Okay. Some of you already know where this is going. Once you have your moles of your thing, then you can come up with a ratio. Now we know the compound is going to be C something, O something. To find out what the somethings are, divide the smaller number into the bigger number, and that's going to give you a ratio. So 4.6 divided by I'll just round up, 2.3 gives you a ratio of what? 4.5. Or 2 to 1, yeah, 2 to 1. Which means our bigger number is going to be 2 and our smaller number is going to be 1. So this is going to be C1O2, or more commonly, CO2.
Whoa.
Okay. So you just turn your percentages into grams, turn your grams into moles. Moles by moles gives you a ratio. That ratio is the number for the empirical formula. Okay. You don't get the ratio? Some people, they have math minds where the ratios will just pop right out at them. And some people have to like do the math. If you're the kind of math person, divide the small number into the big number. Big number over small number will give you the ratio. Yeah?
So when it's 2 to 1, why is the 2 up?
Because there's twice as much oxygen as there is carbon.
Okay.
Good question. Any other questions before we do again? Yeah.
Just round the ratio.
Yeah.
About it.
Yeah, because
Not like, but it's like.
use your best instincts because you're going to be right. Yeah, sometimes you'll get like 0.95 or 0.91 rounded up to 1. Realize, guys, the empirical formula will always be whole numbers. You're never going to get x1, y 2.3. Okay? It's always going to be whole numbers. Okay. Any other questions before we move on?
No.
Then we move on. 40% sodium and 60% chlorine. So we're going to convert that into 40 grams of sodium and 60 grams of chlorine. Do our T-chart. 40 grams of sodium. 1 mole of sodium is going to be so many grams of sodium. And 60 grams of chlorine. 1 mole of chlorine will be so many grams of chlorine, and then we can solve for the moles. So I'll pause right there so let you catch up. My old GoPro had a little screen on the back. I could actually see what it's looking at, but this one has a Wi-Fi thing where you can actually, it'll output the video to Wi-Fi, but then it limits your recording to like 20 minutes. So for those who are having trouble getting started, the moles of sodium to grams of sodium. There are 23 grams of sodium to 1 mole of sodium, and there's about 35.5 grams of chlorine to 1 mole of chlorine. All right, so it sounds like from the chatter that you've got the ratios. How many moles of sodium do we have?
1.7.
About 1.7 moles. And how much of chlorine? 1.7. Hey, that's kind of nice. It's
NaCl.
It's NaCl. Yay! So we have Na1Cl1, most commonly called sodium chloride NaCl. Okay. Table salt. Put it on your French fries.
Wait, I thought table salt.
Table sugar is C11H22O11 or something like that.
I thought table salt was more complicated than I did.
No, just NaCl. I'm sorry. Okay, this one's a little more complicated, guys.
Oh boy.
In so much as now we have 3 different things. So see if you can get it started on your own. I'll be a couple minutes behind you.
How do you say something?
In what language?
Spanish. What are
Algo pasó.
Huh?
Algo pasó. Mr. Bard, should you divide one into the other? Divide that number by that?
Yeah, your smallest number is going to be most likely a 1, and then you'll go from there. Okay. So it looks like most of you are done banging on your calculator. Anyone need more time?
I do.
Okay. Make another minute.
I have to explain what words are. So that misunderstanding. I was writing on one person, and then something happened. Are we going to be doing this with like 5?
No. 3. I want to say 3 will be the most, but there might be one with 4. I think 3 is the most.
So do you just go like biggest to like?
Yep.
I was just this is a 1-to-1 ratio, and then I just divided.
That works fine too. Okay, ladies and gentlemen, if we can come back to order. What do we get for moles for magnesium?
0.8.
Well, about 0.8. All right. And what do we get for sulfur?
0.8.
0.8 again? Okay, that's nice. They're going to be the same number. And what do we get for oxygen? 3.3. So first of all, we know right away that these numbers are going to have to be the same because they're 0.8 and 0.8. And then the oxygen is going to be how many times the other one? 4. So 3.3 divided by 0.8 gives you 4. So simplest thing would just be 1, 1, 4. So this is commonly called magnesium sulfate. Okay. Now, every now and then you get one that's, you might get a ratio like this. 1.5 to 1. Can you have 1.5? No. So if you get this, this is not 1.5 to 1, it's 3 to 2.
Wait, what? Oh.
Uh-huh.
Oh my goodness. How do you know what's multiplier?
You just, yeah, double it. I maybe have to triple it, but usually just double it. But realize these numbers are going to have to be whole numbers. So if you get something that's way off, doesn't round up or down, 1.5 to 1 would be 3 to 2. Okay? Any other questions? I took the biggest number and I divided it by the smallest number to give me the ratio. So 1 to something is biggest over smallest.
What if you had 3 millions like that, but they weren't all the same? Like, 2 of them are the same, so you can divide it. But what if they weren't?
If you had, like, if this was 0.4, then you do 3.3 divided by 0.4. Yeah. And if this was like 1.6, then it would be the smallest number by 2. Because it would be 0.8 to 1.6. Or 1.6 over 0.8. Does that make sense? Okay. Still, divide the biggest by the smallest to get your base number first. Okay. Any other questions? Okay. If there are no other questions, then I leave these for you. Please work these out. In about 15 minutes, I'm going to choose military volunteers to put their work on the board.
As in like write it on the board?
As in, write it on the board.
As in